Hi guys, so today we are going to solve some questions on the topic fundamental principle of counting. So let's start with the first set. Now this is the diagram given to us, and based on this information there are four questions that we have to solve. First question says find the number of ways of going from A to D via Q. Second says find the number of ways of going from A to D if root J and root X are not available. Now we have to go from A to B. So number of ways of going from A to D would be from A to B first and B to C and then C to D. From A to B there are four ways. From B to C there are three. From C to D there are five. So total of 4 into 3 into 5, that's 60 ways. So there are total 60 ways. Now the question says number of ways of going from A to D via only Q. So this means we just have to use Q to go from B to C. So A to B there would be 4, from B to C only 1, and from C to D 5. So 4 into 1 into 5, that's 20. So 20 is the answer to the first question. Second question said number of ways of going from A to D if root J and root X are not available. That means we have to skip the roots which are not available. So, so from A to B there are only three ways. From C to D there are only four ways, and from B to C there are normal three ways. So 3 into 3 into 4, that's 36. 36 ways is the answer. Third question says find number of ways of going from A to D to only one of K and R. To only one of K and R means we just have to use only one root out of K and R. So there would be two things, two possibilities, from K but not R, from R but not K, by applying the same logic. So from K, that means we are just using one root to go from A to B, but not R, that means we are using two roots to go from B to C, and C to D there are 5. So 1 into 2 into 5, that's 10. From R but not K, so not K, that means A to B there are 3, B to C there is 1, C to D there is 5, that's 15. Total of this 10 plus 15, as there is OR, so it is going to be 25 ways. Find the number of ways of going from A to D such that if K is used, then R is not used, and vice versa. Now, over here, it says K is used, then R is not used. But over here, there is no compulsion to make use of one root. So, the question will be same as the previous one, but there's just one addition to it. The addition part is we will not use both the roots, that is neither K nor R. So neither K nor R will also be counted over here. So that would be 3 into 2 into 5, that's 30. So 25 plus 30, that's 55. Understand one thing. Previously it was we have to use one out of K and R. That means it's a compulsion of using one out of K and R. Over here there is no as such compulsion. If there is no compulsion, that means we have to consider the remaining possibility, that is the possibility of not using both K and R. Moving to the next question. 5-digit numbers have to be formed out of digits 0 to 4, 5, 6, 7, 8. How many numbers will be divisible by 20? Now there are 7 digits that we have. So first, we need to find out the divisibility test of 20. Now if you observe, there must be only one digit at the units place, that is 0. And digits at the tens place must be even digits. So units 0 and tens 24680. Now, how many possibilities if there's 0 at the unit place? Only one possibility. For tens, we have 5. For hundreds, there is no restriction, so we can put all 7 digits. Thousands, there's no restriction, we can put all 7 digits. At 10,000's place, 0 can't come, hence we can put the other digits, that is 2, 4, 5, 6, 7, 8. So 6 possibilities. So 6 into 7 into 5 into 1, that's 1470 is the answer. Moving to the next question. 5-digit numbers have to be formed out of digits 0, 2, 4, 5, 6, 7, 8. How many even numbers more than 40,000 can be formed? Repetition of digits is not allowed. In the previous question, nothing was mentioned about the repetition. Hence, we assumed it that the digits can be repeated. In the sixth question, they specifically said that the repetition is not allowed. Now, the numbers, even numbers more than 40,000 can be formed. This is what we have to find. Even numbers more than 40,000 without repetition. Repetition without repetition means unit digit must be 0, 2, 4, 6, 8 because we need even numbers. So for a number to be even, we have to focus on the unit place. The unit place must be even digits only. For 10,000s, we have these 5 possibilities, that is 4, 5, 6, 7, 8. Now there's a note over here. If in without repetition, any digit has dual restriction, take the cases separately. So over here, we have some digits with with dual restriction. This means they're also coming at the units place and also coming at the tens place. That means they are of dual restriction. So we'll take the case separately. So 4, 6, and 8. These are the 3 digits which are coming at both the places. Hence, we can say that they are repeated twice. Basically, it's a dual restriction question. So let's take their case separately and 02's case separately. This is the only difference in repetition allowed and repetition not allowed. You just have to take the dual restriction cases separately. If you figure this out, then you can definitely get the question. Now, we will solve it as we do it according to the concept. So, at units place, only 3 digits can come. Also, 1 digit would be fixed now because repetition is not allowed. So, 4 is gone. At tens, thousands place, only 4 digits can come. So 5 is gone. Now, out of the 7 digits, 2 digits are already eliminated. So at thousands place, 5 digits can come. At hundreds place, 4 digits can come. At tens place, 3 digits can come. And that's it. Now, after multiplying them, we'll get 720 as the answer. Moving to the next possibility. At units place, in the second possibility, only 2 digits could come. So 1 digit is fixed. Tens, thousands place, 5 digits could come. 1 digit is again fixed. So out of 7, 2 digits are eliminated. At thousands place, 5 digits, hundreds, 4, and tens, 3. The product is 600. So 720 plus 600 will give us 1320, that is 1320. So option 2 is the answer. Moving to the next question. 5-digit numbers have to be formed out of 0, 2, 4, 5, 6, 7, 8. How many numbers will be divisible by 4 if every digit can be used only once? Divisibility of 4 says we just have to check the last 2 digits of the number. So let us take these 2 digits together. Now these are the possibilities of numbers having divisible by 4. Now 0 can't come at the thousands place. If without repetition any digit has dual restriction, take the cases separately. So there are 2 restrictions over here. 0 can't come at the thousands place, and 0 408020406080 can come at the last place. Hence, it's a dual restriction. We will take the cases of all the zero parts separately. Now, let's put in the values. So, in the first possibility, six possibilities can come. Two digits are gone because tens and units, these are the two digits. These two digits are fixed now. At tens, thousands place, five digits can come. Thousands place, four digits can come. Hundreds place, three digits can come. The product of this is 360. Now, in the second possibility, there can be only 10 possibilities with two digits fixed already. At tens, thousands place, four digits can come because zero can't come over here. So out of seven, two digits are already fixed, and one zero which can't be considered. Hence, four digits are left. Thousands place, we can consider zero. Hence, again, four possibilities would come because in this case, we can now consider zero. At hundreds place, three possibilities. Product is 480. 360 plus 480 is 840. Answer is option 4, that is 840. Moving to the next question. 8 boys A to H have to be seated on 8 chairs. Find the number of ways in which they can be seated such that D always takes the corner seat. Now D, we know the specific position of. So what we'll do is we'll make D's position fixed at the corner. If we fix D, that means we just have to arrange the remaining 7 children. So 7 children can be arranged in 7 factorial way. Also, D can sit interchangeably, that is on the leftmost corner and also on the rightmost corner. Hence, there are two ways of D sitting. So it will be 7 factorial into 2. Option 4 is the final answer. 7 factorial plus 7 factorial or 7 factorial into 2. It's one and the same. Moving to the next question. 8 boys A to H have to be seated on 8 chairs. Find the number of ways in which they can be seated, such that C and D are always together. Now, C and D are always together. That means we have to assume them as one entity. So if C and D is one entity, there are total of 7 entities, one group and 6 individuals. So we have to make arrangement of 7 entities now. 7 people, 7 children can be arranged in 7 factorial ways. C and D can also sit interchangeably, hence they can sit in two ways. So 7 factorial into 2 is the final answer, which is option 3. Moving to the next question.